Hello everyone, welcome to this video lecture on 8051 microcontroller. In this lecture we will be seeing how to program time delays in 8051 microcontroller without using timers. This method is otherwise called software delay. This lecture is prepared for the benefit of students and other learners who are interested in knowing about the working of Intel 8051 microcontroller. Some of the prerequisites are basic knowledge in assembly language programming and familiarity with the 8051 instruction set. Also, EDSIM51 simulator was introduced in the previous lecture. You may refer it. The topic of today's discussion also includes subroutines. We will be seeing how software delay subroutines are written. Next we will interface LEDs to 8051 microcontroller and write assembly language program to blink them at regular intervals. For this we will be using the delay subroutines that we have written. After this we will copy this program to the 8051 simulator and run it to see its working. This lecture closes with an exercise question as an assignment. Sometimes it is necessary to program certain tasks repeatedly. In order to avoid repeating the program codes for the same task, we use subroutines. A subroutine is a small segment of program that is written separately, but it is accessible by the main program. In 8051 assembly language programming, a subroutine is invoked by the main program using the LCALL or ACALL instruction. The last line of a subroutine is an RET instruction. One should be careful about the data in stack and register banks while using subroutines in 8051 microcontroller. This is because the reset value of the stack pointer is 07H. A suitable method is to relocate the stack to a different memory location. Next we will try to understand delays. One can define delay as advancements in time. While programming real-time tasks, sometimes it is necessary to wait for the right time for a task to be executed. One of the reasons for this is the slower peripheral devices attached to the microcontroller. A delay subroutine becomes useful in such situations. In this slide we will see how a software delay is possible. We know that an 8051 instruction cycle requires 12 clock cycles. For example, if we are using a 12 MHz clock, an instruction cycle requires 1 microsecond for execution. A typical 8051 instruction requires either 1, 2 or 4 instruction cycles for execution. As an example, a few 8051 instructions and their corresponding number of instruction cycles are shown here. Now we shall see the calculations for generating software delays. The following 8051 instructions are written for generating a small delay. We will calculate the total number of instruction cycles required for executing these instructions as shown. By adding the instruction cycles required in each line, we can see that 12 instruction cycles are required in order to execute the given code segment. And we are assuming 12 MHz clock. So the total delay generated by the above code will be 12 microsecond. This method of delay generation is called software delay because the timer modules of 8051 microcontroller are not used here. Now we will take a problem in which 1 millisecond delay is required. Assuming 12 MHz clock, we know that we need a total of 1000 instruction cycles to generate 1 millisecond delay. We will write the following code segment as a subroutine, delay 1 millisecond. Next we will calculate the total number of instruction cycles required for executing this code. Here we have considered a variable count. In the next step we will calculate the value of count variable that will generate the required delay. The following calculations are done as shown and we find that the count variable should be 249. So we replace the count variable with 249 in this subroutine in order to generate 1 millisecond delay. You should realize that this subroutine is not doing any useful task except generating a time delay. Next we will take the case of a 1 second delay. Here also we are assuming the 12 MHz clock. And we know that 1 second equals 1000 milliseconds. We have already written the delay_1 millisecond subroutine that is providing 1 millisecond delay. We will see how this subroutine can be used further to generate 1 second delay. For this we will write a new subroutine, delay1s. In this subroutine we will call the already defined delay_1 millisecond subroutine several times in order to generate the 1 second time delay. Count2 is the counter variable used here. 1 millisecond subroutine is called 4 times here. Now this is repeated count 2 number of times. The calculation shows the value to be used in place of the count2 variable. It can be seen that in order to generate 1000 milliseconds delay, that is 1 million microsecond, the value to be loaded in place of count2 variable is 250. The first exercise that we are going to do is to interface an LED to the 8051 microcontroller. Then we will write an 8051 assembly language program to blink this LED every 500 millisecond. The 500 millisecond given should be taken as the LED on duration only. Further, we will assume 12 MHz clock and 50% duty ratio. Let us discuss about the significance of delay in this particular exercise. You might have studied about persistence of vision in your school. In practice, 500 millisecond time delay is far more than sufficient in between the blinks for human eye to detect it. This figure shows how the LED is interfaced to the 8051 microcontroller P1.7 pin. You may notice that for this connection, making the P1.7 pin low will turn on this LED. Next, we will write the 8051 assembly language program to obtain the desired functionality. This program clears and sets the P1.7 pin repeatedly at regular intervals to turn on and off the LED connected to it. Delay _ 500 milliseconds subroutine is used to generate the required delay for the blinking action. The delay _ 500 milliseconds subroutine is written by making the count2 variable equal to 125 in the delay _ once subroutine discussed earlier. This is the complete program for the given exercise question. The correct syntax for writing the 8051 assembly language program is followed here. Now you can copy this program to the source code pane of the EDSIM51 simulator. Also change the update frequency to 50,000. This parameter can be set according to your PC configuration. Sometimes you have to set a lower value for running the simulator smoothly in your PC. Remember that this setting is only for updating the simulator window and has nothing to do with your program or its execution. Next, you can click on the Run button. The program is now being executed in the simulator. You can see the LED at P1.7 getting turned on initially. Now we will wait for the simulation time to reach 500 milliseconds. See, now the LED has turned off. So our program is working correctly and as expected. We will wait for the simulation time to reach 1 second so that a complete cycle is executed. See, now the simulation time has passed 1 second. And we can see that the LED has turned back on again. Further, you can wait to see the next cycle of LED blinking as the simulation time reaches 1.5 second. Now the LED has turned off and it will continue like this infinitely as per the program we have written. Again, the point to be noted is that the output obtained depends on the wiring of the LED and as well as the program written. Now the exercise question that I am going to give you is to interface two LEDs to 8051 microcontroller. Then write the 8051 assembly language program to blink the LEDs alternately 5 times every 300 millisecond. The 300 millisecond given should be taken as the LED on duration only. You can assume 12 MHz clock and 50% duty ratio. The hint that I can give you is that you need a counter for counting the number of blinks. This video demonstrates the desired output expected from the exercise question. You can see the red and yellow LEDs blinking 5 times alternately. Try to write the 8051 assembly language code for this. Now let us think about the practicality of software delays. We have already discussed that while executing a software delay subroutine, the CPU is not doing any useful task. A software design that takes care of this will be very much complex. Hence, software delays are used for generating very small time delays of the order of a few microseconds in the case of 8051 microcontroller. To do this, a few NOP instructions are added between tasks. For generating larger delays, the 8051 timer modules are used. Discussions on this will be done in the next lecture. You can refer it. These are the websites from where some of the materials were taken. You can visit them.